Hello, everyone. My name is Jason Kierstead, and I'm Chief Architect of Threat Management at IBM Security. And I'm going to be talking to you a little bit today about interoperability between cybersecurity products, how we see that as a challenge in a lot of our customer base, and how the industry as a whole is starting to come together to work to solve for some of this challenge. So first, I just want to set the stage with you about the state of security that we see today. I'm curious, how many of you have a dozen or more different cybersecurity tools? Some customers have 2, 3 dozen. I talk to dozens of different clients every year, and one of the most concerning things that I hear about is how our clients are struggling to maintain and manage all the data and tools that they have. While as an industry, we made a lot of different progress with SIMs consolidating alerts and incident response platforms consolidating workflows, there's still a lot of work to be done. We see that we need to apply the same level of efficiency more broadly and help build a risk-based approach to cybersecurity. More than once, I've heard the term chaos being used to describe the current security operations center. What causes this is limitations on how teams work and what you can see and what you can protect. Because when you think about all the different tools you have, how many of those are truly integrated? Most clients that we see have a few key integrations. Those integrations are a lot of work and they spend a lot of time maintaining those systems. And every time a vendor makes an update to one of those integrations, you have to test, you have to ensure that the critical flow of data from the system still works. And every time you procure a new tool and it's added to the mix, it survives only if your teams can integrate it into existing workflows. More often than not, this means a lot of fragmented workflows from disconnected tools that aren't fully sharing all of their data and insights. And it means countless hours moving data around manually, spreadsheets, searching things from system to system. And now, as many organizations are moving to a multi-cloud world, it's only set to get more challenging if we adopt the same approaches in this new environment. Because of this mess, security teams are missing threats, risks, wasting time, and their companies and customers are suffering attacks. But we think it doesn't have to be like this. We're working on a better way, asking the question, what if security was better connected? What if teams could collect data, connect workflows, and see more immediate results from the various different tools that they have in their operations center? We're somewhat excited about this new possibility, and we think you're going to be excited about it too. On the operations side, it can cost security teams less to deliver on the promise of security. They can stop threats faster, understand and act on risks with more confidence, and position the business to grow. Take the right bets and avoid harmful ones. By connecting the data among your different cybersecurity tools, you'll find that the threats that are hidden in disconnected pools of data come more to the fore. And we know a lot of teams are trying to address this problem with things like data lakes. And for a period, data lakes can add some value, but what we've observed is that these lakes quickly become swamps, and instead of improving your ability to address risk and threats, teams spend their time and money moving data around. And this is only going to get harder and harder as you move to multi-cloud. If you connect your data where it is today, it lets you get more out of your investments. SOCs aren't just about detecting threats anymore. We're moving to a world where you have to make more risk-based decisions and enable cross-cutting use cases. And you can only do that by connecting your data and connecting your tools. It's not just about bringing alerts together. You need to be able to look across all your different data silos and extract those insights across them. This next generation of use cases, one that truly cut across different roles and different parts of the business, they require connected data and connected workflows if we're going to achieve the impact that all these different use cases promise. So I'm going to talk a little bit now about this new organization that we formed in industry to help with the problem that I was just describing. And before I set this up, I want to talk a little bit about what this is not doing, and this humorous anecdote from XKCD about standards perfectly illustrates what we're not trying to achieve with this consortium. We're not trying to basically say, hey, there's a lot of problems with interoperability in this industry, so let's create a new set of data standards to help with this problem, yet again proliferating the problem set in the first place. That's definitely not what we're trying to achieve. Instead, the Open Cybersecurity Alliance project is essentially composed of like-minded vendors, end users, thought leaders, and individuals who are interested in fostering this idea of an open ecosystem for cybersecurity, where vendors and publishers can exchange information, insights, analytics, orchestrated response with common code, tooling, and mutually agreed upon technologies and procedures. What this means is that while all of us in the industry work very hard on interoperability today, we believe we can do so much better to create more out-of-the-box solutions that share the full depth of insights, so that organizations can focus more on effectiveness as opposed to integrating their products together. And, you know, a lot of the different participants in this endeavor are people who you may classically think of as competitors. And what we recognize is that cybersecurity is a team sport, and the only way that we're going to be able to effectively work against the adversaries is if we collaborate and share data and share insights among our different products to enable better outcomes for all of our customers. So here are the goals of the Open Cybersecurity Alliance. The first goal is to develop and promote sets of open source code, tooling, patterns, and practices for sharing data among the tools. And the thing I want to emphasize about this goal is open source. So everything that the OCA creates is going to be open source code. What that means is that any customer or vendor or anybody else in the industry can adopt this code for free of charge, regardless of whether or not they're a member of the Alliance. And what this allows them to do is to more effectively integrate their tools and their processes with other products and processes in the cybersecurity industry. And that plays into the second goal, is to enable vendors who make use of this to seamlessly operate. So the whole idea is this idea of integrate once, reuse everywhere. I like to think of this as creating more of an ecosystem of ecosystems, where all of the various different cybersecurity enclaves of data and products can start exchanging data in a more seamless fashion out of the box without a lot of hand-holding or customization. And these goals are to facilitate a variety of different use cases, including threat hunting and detection, analytics, operations, security response, and more. Essentially, we're not trying to box ourselves in. This is not an organization that's focused on any one piece of the cybersecurity domain. It's definitely trying to span the entire problem set of how to share information among products and tools and people. The group's going to utilize and interoperate with existing standards and protocols. This plays back to some of the earlier discussion around how we are not trying to create new competing standards out of this effort. Wherever there's existing data interchange standards that exist, such as STIX for threat intelligence and cyber observable information, or OpenC2 for command and control response, or OpenDXL for real-time data interchange, we're going to use those tools and standards that already exist in the industry. We're not trying to create new things that compete with standards that are already in wide use. When there are gaps in these existing standards, the OCA may decide to extend them and contribute that work back to the existing standards bodies that create these. So, for example, if OCA was to use the STIX data format to exchange data between threat intelligence tools and security operations tools, and we decided we needed a new field on the network traffic object. Once we defined that field and adopted it and proved it in our tool chain, we would be able to contribute that back to the Cyber Threat Intelligence Technical Committee to get that added into the standard. These different formats are going to be enabled by OCA deliverables. So what that means is code. Everything we do in OCA is real code. The mantra is code before paper. We create the software that enables this interoperability first before we submit that to standards track. And some of the activities will be pure software, and that is all that will exist. Some outputs from the OCA may eventually evolve into full OASIS standards, depending on the wishes of the community. So what makes this alliance different? And we've gotten this question a lot. You know, groups come to us and say, there's so many alliances that already exist. And we want to say that this organization is focused on providing technologies to enable deep and fundamental interoperability challenges in the cybersecurity space. We're not focused on things like sharing threat intelligence. Members of the OCA are not sharing data. We're not sharing intelligence between ourselves. Like I mentioned earlier, we're not a standards body. We're not going to creating new data standards here that compete with things from the IETF or from OASIS or from W3C. We're not a cybercrime focused organization, so we're not necessarily going after the hackers and cyber criminals or trying to do education to the public. And we're not a cloud operations alliance like the Linux Foundation or the Apache Foundation, where they're focused on tool chains and developing open source, but it's not really cybersecurity focused. So this group is being basically kickstarted by a couple of key initial contributions. And I'm going to talk about what those contributions are in detail in a moment. The first initial contribution is from IBM Security, and it's called STIX Shifter. What this contribution allows is data federation among many different platforms to normalize the data, allowing for cross-platform threat hunting and analytics use cases. The second initial contribution is this project called Dxl Ontology. And what Dxl Ontology is a new project to allow common and aligned formats on top of the Dxl messaging system, so that projects that are using the system to exchange messages know what the different format of these messages are. And I want to emphasize that these are just the initial two contributions that are going to be starting this work effort. There are a number of contributions that we're under discussion, with numerous partners right now, which are going to solve other fundamental interoperability issues that should be introduced into the OCA shortly. And because it's an open project, we welcome any contributions from the community to help solve some of the interoperability challenges that were laid out. So let me go into a little bit of detail on the STIX Shifter project and what that is. Organizations that we see are enabled to easily integrate security data from a number of different products and tools. So you see here in this picture of on the left of all of these different data lakes and clouds that a typical threat hunter or research analyst has to access while they're troubleshooting an incident. Some of our enterprise clients have multiple different SIEMs, they have multiple different EDR tools, they have many data lakes that exist in the cloud. And you know, the reason that these things can proliferate can be a number of different reasons, including acquisitions. It can include migrating workloads to the cloud. It can include subsidiaries and other segregations that mean it's impossible to send all of your data to one SIM. And it can also just be due to migration strategies where you're procuring a new EDR tool, but you're not able to get rid of your existing EDR tool for a number of years because it's going to take you that long to migrate. And while you're doing that, you have to deal with two of them at the same time. So we see this proliferation in our enterprise client base. It's extremely common. And we started to ask the question, what if instead of trying to bring all of your data to one place to do threat hunting and analytics across it, you could leave it where it is and connect the data anywhere and share those insights together. And that's why we created this open source project. What StickShifter allows you to do is connect across all of these different data silos using Stix patterning and do bidirectional transformation. So essentially, you take a Stix pattern in, and for those who don't know what Stix pattern is, Stix patterning's goal is to encompass all three fundamental security data source types, network, file, and log, and allow you to query across those simultaneously so that you can create complex queries that span different cybersecurity domains. So StickShifter, it lets you create search patterns that span the SIM, endpoint, network, and file spaces and allow you to detect complex patterns that are used in modern campaigns that span all of these different activities. And you can do this across all of the different data silos, no matter whether they live on-premise or in the cloud. The second project is this Dxl Ontology project. And why OpenDXL? The reason is multiple, but first it is this, first of all, open source technology. So once again, everything that OCA does is very important that it's open source and freely available to all. And secondly, it's proven to be highly scalable and is in heavy use in the industry and has a growing ecosystem that has grown beyond the original vendor space in which it was created. And what the OpenDXL Ontology project is this effort to try to normalize on a common ontology and vocabulary for messages and their formats that move on top of the OpenDXL bus. And the reason this is important is so that when, for example, multiple different EDR tools or multiple different user behavior analytics tools are connected to the messaging system and are sending messages either amongst each other or to other different tools, that they all speak a common language and a common vocabulary. And it is that language, common language and vocabulary that is important. It creates something called an information architecture. The reason that information architecture is important is because it's what you base all of your analytics, machine learning, and insights extraction from. Without a common information architecture, your data tends to be harder to get value out of because the various different tools are encoding the data in different ways. And this is why when you're looking at the typical workflow for developing machine learning and artificial intelligence analytics, there's a very large time-consuming portion called data cleansing that has to take place. It's because of this need to create a sane information architecture before you develop your analytics. So one of the whole goals of the OCA is to develop this information architecture and use it throughout all the different projects, including the OpenDXL Ontology, so that the data always looks the same no matter where it's coming from. This lets you build analytics and tools that are no longer tied to specific end products or specific use cases. So for security vendors, what that means is you can reduce your integration expenses. So most cybersecurity vendors, such as, for example, IBM Security, We have networks of hundreds of different partners that we have to develop integrations for, and this is common in the industry. With the Open Cybersecurity Alliance project toolchain, the goal is that you build an integration using this common set of tools, and everyone else who has adopted those tools can now integrate with each other. And over time, as we get more members supporting this initiative, the goal is that you reduce your integration expenses. And you can use that reduced expense to now focus on higher value features and functions for your software. Also, you should end up with an improved robustness of data integrations, so that not only are you reducing your expenses, but your integrations are now more robust, so you can extract more value out of your existing tools. For security practitioners, there's a number of benefits as well. For example, this more improved robustness of integrations is going to let you discover new insights and findings that you previously would have missed. Because of this time-consuming activity of having a large number of your security operations personnel dealing with integrations instead of looking for threats, when things more seamlessly interoperate, you can detect more threats and find things that you otherwise may have missed. The second benefit is reduce the unnecessary procurement of new tools. So we see this a lot. There are a large number of tools, as we mentioned earlier, in the Cybersecurity Operations Center. And because they're poorly integrated, the client is unable to extract the expected value out of these tools. So they go off looking for a new and improved tool that they hope will solve their problem. And when the reality is they don't need a new tool. Their existing tools could detect the threats that they're looking for if only they were integrated better. And finally, the reduction of vendor lock-in. Because when everyone is speaking the same language and sharing the same data, it's a lot easier to swap one tool out for another in the same space while maintaining all of your integrations and features. Whereas when things are developed using proprietary point-to-point integrations, swapping one tool out without swapping the other out is a lot more challenging. So this reduction of vendor lock-in is an advantage that a lot of security practitioners appreciate. So let's talk a little bit about how this foundation operates and what an OASIS Open project is. An OASIS Open project supports the shared community development model of code, standards, and reference implementations. An open project has the freedom to develop whatever code they choose, APIs, reference implementations, guidelines in one place under common open source licenses with a path to global policy and procurement. What that means is the outputs of the OCA, in addition to being just code, have the option to be able to be submitted for ISO standard status, ITU standard status, etc. Open projects is a parallel track to the typical standard track that a lot of people are familiar with. There's a few key differences, though. The first being the aforementioned that these projects always operate under open source licenses. The second is this fact that anyone can contribute. So again, you do not actually have to be a member of the Open Cybersecurity Alliance to contribute code or to consume the code or activities out of this alliance. It's freely open to all. Another key difference is that the project is directly funded by its sponsors as opposed to the main membership funding model of the OASIS organization. And it can develop code and APIs and reference implementations all in one place, as well as specifications. As an open project, the OCA will have a project governing board, a technical steering committee, and repositories for the aforementioned OpenDXL and stick shifter, as well as any other contributions that come up. Beyond that, the Alliance can form whatever new repositories and working groups as it sees fit at any time. This project governing board provides the top level governance for the Open Cybersecurity Alliance, and anyone that sponsors the OCA can have a seat on the PGB. What the PGB does is it essentially provides the overall guidance and, to the organization and allows the various stakeholders to ensure that the work stays on track. While the Technical Steering Committee, which is appointed by the PGB, is who handles the day-to-day technical work of the project. And it can take on release management, adopting maintainers, etc. The members of the Technical Steering Committee can be appointed leaders from the community. So they do not necessarily all come from the project sponsors. They can come from anyone in the industry. And we look forward to selecting our initial set of Technical Steering Committee members later next week. The way that the governing process works is an extension of the OASIS TC process. The initial repositories operate under Apache 2.0 licenses. OASIS currently supports 6 other OSI approved licenses, such as BSD and MIT and a few others. So you're able to add repositories under different licenses in the future if that's something that the OCA chooses. The governing board works with the Technical Steering Committee to decide what level of approval is right for each deliverable. Some parts of the work might remain as releases, and some may be advanced as project specs. Some might go from there to the standards track for approval as OASIS standards. And if the project governing board so chooses, some of those deliverables might be submitted to a de jure body like ISO, IEC, ITU, etc. if the PGB decides to do that and request it of the OASIS staff. So that's a high-level overview of the OCA, how it works, why it was created, and what it's trying to achieve. And in closing, I just want to say that we've had a remarkable groundswell of support for the OCA ever since we launched it a couple of weeks ago. And it's been a very exciting journey, and we firmly believe, the members of the OCA, that it's set to solve some fundamental challenges in the industry. And we hope that you can start getting involved, getting on board, regardless of if you're a client, consumer, customer, or vendor. This problem set and challenge is one that's facing all of us on a daily basis. And the more supporters that we can get involved in this group, the better we can hopefully solve for this problem set in the industry and overall make the world a safer place.